Hi guys, good morning everyone. Is my voice audible for the people who are watching in the Zoom and who are watching in YouTube live? Yes, good. Thanks for confirmation. Guys, all of you welcome to Ashok IT. Today we are here to understand what is Docker, why Docker, and how to work with Docker. What is the importance for the Docker in the real-time projects implementation? Good. Before going to start, this is one-day workshop. It's like a crash course on the Docker. This workshop will be available for 2 to 2.5 hours of time, and we will understand theoretical part as well as practicals also on the Docker. Good. Once this workshop got completed, I will share the required notes, materials, and the backup video also will be available for you people. I'm sharing a WhatsApp group link in the chat box. So if you join in that group, you will get all the documents after the session got completed. Got it. Have shared WhatsApp group link in the chat box. All of you can join in that. Good. Fine, guys. Let's get started. So first of all, what is Docker? First of all, what is Docker? Some people will say Docker is a DevOps tool. Every DevOps engineer should know Docker. So Docker is not only for the DevOps engineers, even developers also should know what is Docker. So we can say Docker is used for containerization. It is a containerization tool. Docker is used to perform containerization for our applications. Here comes the biggest question. What is containerization? So before going to understand what is a containerization, first we need to understand our application architecture. So in simple terminology, to give the definition for the Docker, so we can say what is Docker, and Docker is a containerization software, but it's very high level terminology. What is that containerization? So before getting into containerization part, let's understand application architecture. If you take any project, you can see front end will be available for the project, back end will be available for the project, and the database also will be available for the project. So database is used to store our application data. There are so many databases available in the market like Oracle, MySQL, SQL Server, MongoDB, etc. There are so many databases available. Depends on the requirement. We will use one database for our application. Along with that, for every project, backend will be available. Backend contains business logic. So the business logic will be implemented in the backend. To implement backend of the application, there are several technologies are available. Java, .NET, Python, PHP, Node.js, like that. There are so many technologies are available. By using those technologies, we can develop backend of the application. Backend contains only business logic. Then coming to the front end, user interface. Whatever you see on the browser, that is called as user interface. That is also called as front end. In order to develop front end of the application, we are going to use several front end technologies like Angular, React, or Vue.js. Like that, there are several front end technologies are available. By using those front end technologies, we are going to develop the user interface of the project. Guys, for all of you, is my voice clear? Is my screen and voice clear for everyone? Yeah, good. So a project contains 3 layers, guys. Front end will be available, back end will be available, and database will be available. So this is application architecture. So when we are talking about a project, a application contains front end. That front end, nothing but user interface, and back end will be available, and database will be available. So front end is used to develop user interface. To develop the front end, there are several technologies like Angular, React, Vue.js. Like this, there are several technologies are available. To develop backend of the application, there are several technologies like Java, .NET, Python, PHP, etc. Like that, there are several technologies are available to develop backend of the application. Coming to database, for every project, database is mandatory. So like Oracle or MySQL, or SQL Server. Like that, there are several databases are available. Now, let us take one example. Suppose I want to build one project. I want to develop one project and I want to deliver that project to the customer. Now, we need to take application tech stack. We need to take the application tech stack. That means what are the technologies we are going to use to develop our application? That is called application tech stack. So here for the front end, I'm using Angular. Assume that. For the front end, I'm using Angular 13 version. And for back end, I'm using Java 17 version. And for a database, I'm using MySQL 8.5 version. MySQL 8.5 version I'm using. So this is called application tech stack. So I want to develop a project. For the project development, we are going to use Angular 13 version for the front-end development. And for Java, for back-end development, we are using Java 17 version. And for a database, we are using MySQL 8.5 version. Now fine. So in order to develop this application, we are taking these technologies. Then after, once the project development got completed, development team will be available. The development team is going to write the code, front-end code, back-end code, database queries. They will develop a project. Once they develop the project, we need to deploy this application. So developers should run this application and DevOps engineers should deploy this application in the higher environment. Okay. So now we need to understand environment setup to run our application. So what we need to do in order to run our application? In order to run our application, we need a platform. Development team completed the coding part and they have stored the code into GitHub. Now, it is the responsibility of the DevOps engineers to deploy this application in the higher environments. So in order to deploy this application, DevOps engineers should prepare an environment. So what they have to do, take one machine. So we can say it is a physical machine or virtual machine. Anything is fine. A physical or virtual. So we need to take one machine. After that, install Angular 13 version, because to run the front-end code, Angular software is required. So if you want to run your application in a computer, then you need to take one computer with OS. That can be a physical machine or that can be a virtual machine. Install Angular 13 version in that machine. Then after, install Java 17 version. Install Java 17 version and install Tomcat server. Because to run the Java application, Tomcat server is required. Install Tomcat server 9.0 version. Then after, install MySQL database server. Install MySQL DB server 8.5 version. So this is called as environment setup. We are working on a project. Our project is having front-end, back-end, database. For front-end, there are so many technologies are available. We are using Angular for the front-end development. Back-end, we can develop by using multiple technologies. We are using Java 17 version to develop the back-end of the project. There are so many databases available. For our project, we are using MySQL database, which is 8.5 version. Got my point? Good. Now here, in order to run this application, we need to prepare the environment. Environment setup is required to run our application. So how environment setup will be done? DevOps people are going to do this environment setup in order to deploy and run our application. They need to take one computer. That can be a physical computer or virtual computer. And they need to install Angular software, because to run the front-end code, Angular is required. And to run the back-end code, Java software is required. They need to install Java version. And they need to install Tomcat server 9.0. To run the Java application, the Tomcat server is required. And they need to install MySQL database server so that our application can communicate with the database. This is environment setup. That environment setup we have to do manually. DevOps engineers has to perform this environment setup manually in order to run our application. How many times they have to do this environment setup? How many times they need to deploy our application? So in the real time, we will be having multiple environments, guys. Those are called as application environments. Once the coding is completed, directly we are not going to deliver that code to the client. Our application will be tested in the multiple environments. Like we will have dev environment, we will have SIT environment, we will have UAT environment, and we will have pilot environment, and we will be having prod environment. So these are called as application environments. Dev environment, developers will use this environment for developers integration testing. Developers will use it for developers integration testing. All the developers code will be integrated at one place, like source code repository server will be available, like a GitHub or Bitbucket. In a project, there are 10 developers available. All the developers code is integrated at one place. Now, once the code is integrated, whether that code is working as expected or not, we have to test it. For that, all the developers code will be integrated and that code will be tested by the developers only. For that testing purpose, we need one environment called dev environment. What is the meaning of a dev environment? A separate platform, a separate environment. So they need to take one computer, install all the required softwares and deploy the application. Okay. So now dev environment will be used by only developers to perform integration testing. Then similarly, SIT environment will be available. Testing team will use it for system integration testing. Developers will do developer integration testing, whereas testing team will use it for system integration testing. Again, another environment. Another environment means, again, they need to take a computer, again, install all the softwares to run the application. So environment setup to run our application is a difficulty here. Then what is UAT? Client will use it. Client side team or client. Client will use it for acceptance testing. Okay. So whatever the application we have developed, is that application working as expected or not? Client has to approve that. For that, we are going to give our application for the client as part of UAT. UAT stands for user acceptance testing. So UAT is a separate environment. Client will use this UAT environment for acceptance testing. Then pilot. Pilot is nothing but pre-production environment. Okay, pre-production environment. Before our application will be given to the client for in the production environment, our application will be tested again in the pilot environment. Then finally, once the pilot testing is completed, then we will go for the prod. Prod is nothing but live environment. So end users can access our application from the prod. End users can access our application running in prod. Prod environment will be available. Any application that we are accessing through internet, nothing but it is from the prod environment. Production environment, nothing but live environment. Production, nothing but live environment. So in the real time, once the developers development got completed, once the developers coding got completed, our application will be deployed into multiple environments for a testing purpose. So in the real time, for every project, multiple environments will be available, like dev environment, sit environment, UAT environment, pilot environment, and prod environment. Who will use the dev environment? Dev environment will be used by developers to perform integration testing. What is the meaning of integration testing? So multiple developers are working, they will work on different functionalities. Once the code is integrated, all the developers code working as expected or not, that verification process is called integration testing. Okay. Once the developers integration testing got completed, then our application will be deployed into SIT environment. So testing team will use it for system integration testing. SIT will be done for our application. Testers will be available. The testers are going to test our application. For the testers, separate environment will be available. UAT. Client will use it for user acceptance testing. UAT stands for user acceptance testing. Before going to deliver the project to the client, we will give for the trial run. Client will check, is everything working as expected or not. Once UAT completed, our project will go to pilot. Pilot, nothing but pre-production environment. Before deploying our application to the live environment, we are going to deploy the application in the pilot environment. Okay. And the next one is prod. Prod is nothing but live environment. end users can access our application running in the prod environment. Now, if you see here, there are multiple environments available. There are multiple environments are available. Now, in order to deploy our application into all these environments, like here, dev environment is available and sit environment is available, UAT environment is available, pilot environment and production environment, like that. Multiple environments are available. Can you guys tell me what is the environment? Now, so here we need to install Angular, okay? Then install Java, and Angular also very specific. 13 version should be installed. Install Java 17 version. Then install Tomcat 9.0. Install MySQL 8.5. So this is called environment setup in order to run our application. This is environment setup to run our application. Now this is called as dev environment. So this is one machine. In that machine, we are installing all the required software. Then we are going to run our application. Okay. So the same thing is required when you go for SIT environment. So again, we need to take one more machine. In that machine, we need to install all the softwares. So that is called as SIT environment. Again, we need to take one more machine for the UAT, and we need to install all the softwares in order to run our application in the UAT. Same thing we need to do for the pilot. So before giving the project to the customer, before delivering the project to the production, we are going to do the pilot testing. Pre-production testing will happen. Once the testing is completed in all the environments, then finally we are going to take one more machine and we are going to install all the required softwares. That is called as production environment. So that is called as production environment. So in the real time, our application will have multiple environments for testing. Our application will have multiple environments for testing. Okay. So environment, nothing but it is a platform where we can run our application. Guys, now, if you observe, is there any challenge in our application deployment process in the real time? Is there any challenge? Is there any challenge to run our application in the multiple environments like this? Is there any challenge or there is no challenge? Can you see any challenge here or there is no challenge here? What is the challenge here? What is the challenge that you have observed here? Can you tell me? That will give the answer for what is Docker. What is the challenge here? We have to install the required softwares in all the machines wherever we want to run our application. Okay. So today I am having only 5 environments. In the 5 systems, I have to set up all the required softwares. And the most important thing is software version conflicts. Software version conflicts. So in the dev environment, already Java 11 version is available. But for our application, Java 17 version is required. There is a chance of getting version conflicts when we are running our application in multiple systems for testing purpose. We should be very careful when we are installing the software to run our application. Okay. And so to set up this platform, set up this environment, manually they are going to install all the softwares. Humans are going to do this setup. There is a chance of doing the mistake. Now, so here the challenges, version conflicts can occur. So whatever the machine I am taking in order to run my application, in that machine already Java 11 is available. Okay. But for our application, Java 17 is required. Okay. Version conflicts can occur. Okay. So setting up environment setup is time-taking process and it is error prone. That means a human is going to do this environment setup in order to run our application. A human is going to do all this setup. So there is a chance of getting errors. So we can do some mistakes also. And repeated work. Setting up the multiple environments is a repeated work. And for example, tomorrow our application is upgraded from Java 17 to Java 21, Angular 13 to Angular 14. We got some new features in the Angular and Java new versions. I want to migrate my application to Angular 15, and I want to migrate my application to Java 21. Then what I need to do? We have done all the environment setup in order to run our application. But after 3 months, we got the upgradation request. We need to upgrade our application front end to Angular 15 or Angular 14, and Java version we need to upgrade from 17 to Java 21. Then is it easy? Guys, is it easy? Come on. You need to uninstall all the softwares available in all the environments. And again, you need to install new version of the software, and you need to run your application. So that maintenance cost will be high. So today I have only 5 environments. For example, so we are working on very large scale application. We have 10 environments to test our application. Then can you imagine the scenario? Now, can you imagine the scenario? If you want to test your application in the 10 environments, 10 computers you have to take. In 10 computers, you have to set up all the softwares to run your application. Okay. And if any version upgrade is required, then the things will become very complex. You need to uninstall Angular and Java from all the systems, and again install the latest version of Angular and Java, then deploy the application, then test that application is working as expected or not. So here, is there any guarantee the application which is working in one system will execute in all the systems in the same way? Is there any guarantee? The code which is working in one computer in the dev environment, can you guarantee that code will work in all the environments? No. It depends on the softwares we have installed. It depends on the platform. It depends on the versions of the softwares we have installed. Then what issues will occur, in the real time? Developers will say that the code is working in my system properly. Testers will say that the code is not working in our system. Then in the dev environment, whatever the code is working as expected, the same code is not working in the SIT environment. Then the fighting will happen between the developers and testers. Developers will blame the testers. Testers will blame the developers. So these are called environmental issues. These are very common in the real time. The code which is working in the dev environment, the same code is not working in the SIT environment. The reason? Environment issue, not the code issue. Sometimes code issues also will be available. We have to accept that. Most of the times when we are going for the environment, we should be very careful about the environment setup in order to run our application. So this is the biggest challenge. This is the biggest challenge in the real time to test our application. Are you guys able to understand? So we are trying to understand that an application will be available. Application contains 3 layers. Front end will be available, back end will be available, and database will be available. So we need to use one database, one back end technology, one front end technology to develop the application. So here I'm taking an example. My project front end is developed by using Angular, back end is developed by using Java, and MySQL database we are using. So that is called tech stack of the application. Here I have decided the application tech stack. Angular 13 version I'm using for the front end. Java 17 version I'm using for the back end. MySQL 8.5 version I'm using for the database. Okay. And in order to run this application, I need a Tomcat server. That Tomcat server I'm using 9.0 version. To run the Java web application, Tomcat server is required. I'm using Tomcat 9.0. Okay, guys. Then once the application development is completed in the developer systems, all the code is integrated. Now, as a DevOps engineer, we need to integrate that code and we need to deploy that code into multiple environments. First of all, what is environment? Environment, nothing but a platform where we can run our application, right? In the companies, multiple environments will be available in order to run our application. how they will do environment setup. So they will take one machine that can be a physical machine or a virtual machine. Then they will install required softwares. For our application, front end is Angular 13 version, backend Java 17 version, Tomcat Server 9.0 version, database 8.5 version. These softwares should be installed in the machine in order to run our code. These are called as dependencies of our application. Okay, so in my application code is available. In order to run that code, Angular 13 version should be installed in the computer. Java 17 version should be installed in the computer. Tomcat Server 9.0 version should be installed. MySQL database server 8.5 version should be installed. Can we call these things as dependencies of our application? Can we call them as dependencies of our application? Yes, we can call them as dependencies of our application. So the deployment team, the operations team should set up all these dependencies in the system to run the application. How many places they need to set up these dependencies? That depends on project to project. Okay, so in the real time, for every project, multiple environments will be available, like dev environment, sit environment, UAT environment, pilot environment, and prod environment. Okay, so dev environment, sit environment, UAT, pilot, and prod. Got my point? Here, who will use this dev environment? Dev environment will be used by developers. Developers will use it for integration testing. All the developers' code should be tested at one place. For that, they will use this dev environment. Testers should test our application. For that, we will have a SIT environment, that is system integration testing. UAT, client will use it for user acceptance testing. Okay, pilot, pre-production environment. Before deploying our project to the production, we will use it. We will test it in the pilot environment. We'll test it in the pilot environment. Prod is a live environment. End users can access our application running in the production environment. Now, environment setup is a challenging task, guys. Challenges in deployment process. Can you tell me what are the challenges in the application deployment process? So once the code is completed, directly, we are not going to deliver that code to the client. Our application should be tested in the multiple environments. Okay, challenges in the deployment process. The first thing is environments setup. Environments setup is the first challenge. Okay, and setting up required dependencies. Dependency is nothing but softwares, guys. So the front-end software, back-end software, database software, setting up required dependency is one of the challenging tasks. So setting up multiple environments setup. It's not one environment. In the real time, multiple environments will be available. We have to set up those environments, and we have to set up required dependencies. Okay, version conflicts. Our application requires Java 17 version, but by mistake they installed Java 11 version. The code which is implemented with Java 17 version will not work with the Java 11 version. Such kind of version conflicts will occur. And the second problem is environment maintenance. Environment maintenance is another biggest problem. Okay, environment maintenance is another biggest problem when you go for this multiple environments. Are you guys getting my point? So what are the challenges in the deployment process? Multiple environments setup and setting up the required dependencies. That means what are the softwares that are required to run our application, setting up all required softwares in all machines. So I have 10 environments. Okay, in the 10 environments, I have to set up all these softwares. 10 environments are available. I have to set up this 10 environments. But guys, now version conflicts. My application requires Java 17 version, but by mistake they have installed Java 11 version. Then my application cannot work. Are you guys getting my point? Okay, tomorrow if I want to change the version, then what is the issue? Then what is the issue, guys? If I want to change the version, then what is the issue? Need to uninstall and install. Environment maintenance. Okay. Environmental issues will occur. The code which is working may not work in the code which is working in one environment may not work in all the environments. The code which is working in the one environment may not work in other environment. Then teams will try to blame others. Teams will try to blame others. Got my point? Developers are saying that the code is working in the dev environment properly. We have done very good coding. The code is working in the dev environment properly. But testers are saying that the code is not working in the SIT environment. The reason? In the SIT environment, by mistake, they have installed Java 11 version. Actually, our application requires Java 17 version, but some mistake happened in the SIT environment. Java 11 version is installed. Because of that Java 11 version, the code is working. The code is not working in the SIT environment. Then the fight will happen between the developers and testers. Are you clear? Are you guys clear with my point? Are you guys clear with my point? People who are watching from YouTube live, give me a like for this video and give me a comment. People who are watching from YouTube live, give me a like for this video, smash that like button and give me a comment whether you are able to understand or not. Perfect. So with this, we understood what are the challenges that we face in the industry to run our application. Okay, what are the challenges we are facing in the industry to run the application? Now, to overcome all these challenges in the application deployment process, we are going to use Docker. To overcome all these challenges in the industry, we are going to use Docker. Okay, so now we need to understand what is Docker and how Docker is going to solve these problems. First of all, before getting into the solution, are you clear with the problem that industry is facing? Are you clear with the problem that industry is facing? Yes, the problem is environment maintenance. Running our application in multiple systems is very difficult. Okay, running our application in the multiple environments is challenging. Running our application in the multiple environments is challenging. Environment setup is going to take time. Environment setup is going to take time. So to overcome this problem, we are going to use a concept called Docker. Okay, so now when you go for the Docker, so let me tell you, when you go for the Docker, you no need to install all these softwares. When you go for the Docker, you no need to install all the softwares. Without bothering about the required softwares, you can run your application in any computer. Okay, you want to run your application in the 10 computers. Happily, you can run your application in the 10 computers also without bothering about the software's installation. What are the softwares are required? What are the dependencies? Instead of calling them as softwares, we will call them as dependencies. In order to run my application, Angular dependency, Java dependency, Tomcat dependency, MySQL database dependency. Instead of we are setting up all the dependencies to run our application, Docker will take care of required dependencies to run our application. If I use Docker, I can run my application in any computer without bothering about the dependencies. So you just need to run your application. Docker will take care of the setup required for the application execution. So if we don't use Docker, you need to set up all the softwares to run the application in the computer. In any computer, if you want to run the application, you need to set up all the dependencies. But when you go for Docker, Docker is going to take care of everything that is required to run our application. Docker is going to take care of everything that is required to run our application. Are you guys able to follow me? Are you guys able to follow me? What is Docker? It is free. It is free and open source software. Docker is free and open source software. It is used for containerization. It is used for containerization. Okay. So Docker is called as a containerization software. Guys, don't get confused. Kubernetes, we are not discussing today. We'll conduct a workshop in the upcoming weekends for the Kubernetes. Kubernetes is called orchestration platform. Docker is called as containerization platform. So we are using Docker for the containerization. We are using Docker for containerization. What is the meaning of containerization? Containerization means package our application code plus required dependencies as single unit for execution. That is called containerization. So now it's very important. We understood the problem. Now we are going for the solution. So the solution is Docker. So the environmental issues will be available. Managing all these environments, setting up the required softwares in all the environments is very difficult for the operations team in the real time. So then how can we avoid this problem? How can we avoid this problem? In order to avoid this problem, we are going to use Docker. Okay. What is a Docker? So Docker is a free and open source software. Why we are going to use Docker? Docker is used for containerization. Docker is used for containerization. What is the meaning of containerization? Containerization means package our application code plus required dependencies as a single unit for the execution. So what is the meaning of that? So here, let's understand. My code is available. My application code is available. This is my application code done by the developers. In order to run this application, I need some dependencies. What are the dependencies are required? I need Angular 13 version, and I need Java 17 version, and I need Tomcat 9.0 version, and I need MySQL 8.5. Okay, these all are called as dependencies. So this is my application code and these are my application dependencies. So what we can do by using Docker? So by using Docker, we are going to package application code plus application dependencies as single unit. We are going to package application code plus application dependencies as a single unit. That single unit is called as a Docker image. That single unit is called as a Docker image. So whatever the application code is available, what are the dependencies that are available to run our application, we are going to package application code plus application dependencies as a single unit. That single unit is called as a Docker image. Once the Docker image is created for the application, we can run our application in any computer without bothering about the dependencies. Now, if I want to run my application into one environment called a dev environment. Now, I want to run my application in the dev environment. So for the dev environment, do I need to set up any softwares, or simply I will take the Docker image and I will run the Docker image? Do I need to install the softwares, or I no need to install the softwares, guys? Do I need to install the softwares, or I no need to install the softwares? I no need to install the softwares. Why I no need to install the softwares? Because the software's installation will be taken care by Docker. The software's installation will be taken care by Docker. Okay. So now, this concept is called as containerization concept, guys. This concept is called as containerization concept. So what is the meaning of containerization? Containerization nothing but package our application and application dependencies. Application code plus application dependencies, we are going to package as single unit. We are going to package as single unit for the execution. Application code plus application dependencies will package as a single unit. that is called Docker image. Once the Docker image is created, you can take the Docker image, you can run in any computer. So here I am having a dev environment. So when I take the Docker image, when I run the Docker image, here it is going to create a Docker container. So when I run the Docker image, a Docker container will be created. Inside the Docker container, our application will execute. To execute our application, what are the dependencies are required? Those dependencies will be taken care by Docker. That means we can run our application in any platform. We can run our application in any platform without bothering about the required dependencies. Now, I got a requirement that I want to run my application in the SIT environment. So as a DevOps engineer, what I will do to run the application in the SIT environment? Simply, I'm going to take one machine. In that machine, I'm going to take the Docker image and I will run the Docker image. When I run the Docker image, then what will happen? When I run the Docker image, Docker container will be created. That's it. What about the softwares? Softwares will be taken care by Docker only. So if you want to run your application in the multiple environments, what you need to do? You just need to take the Docker image and you run the Docker image. You just take the Docker image and you run the Docker image. When you run the Docker image, it is going to create Docker container. So Docker container will execute our application. This is our UAT environment. So similarly, I want to run my application in the pilot environment as well as in the production environment. Then what I will do? So I will take a computer for the pilot environment and for the prod environment, I will take a computer. So here what we need to do? Just you take the Docker image and you run the Docker image. You take the Docker image and you run the Docker image. So when you run the Docker image, then it is going to create a Docker container. Okay. So the Docker container will be created. Inside the Docker container, our application will be executed. So this is my pilot environment. And this is my prod environment. Now, the application deployment process got simplified or not? The application deployment process got simplified or not? Come on, guys. The application deployment process got simplified or not? So earlier, we are responsible to install everything that is required to run our application. Now, we are not responsible to install the required software. Who is going to take care of the software installation? Docker is going to take care of the software installation. Now, so here, the code which is executing in one environment, confidently can I say that that code will execute in the other environments also? The code which is executing in one environment, can we say that that code will execute in the other environments also? Yes, because who is taking care of the software installation? Who is taking care of the software installation? Are we taking care of the software installation, or the Docker is going to take care of the software installation? Docker is going to take care of the software installation. Earlier, we are responsible to take care of the software installation. Now Docker is responsible to take care of the software installation. That means, so we can simplify the application deployment process in the multiple environments. So this concept is called as containerization. So Docker is a free and open source software. Docker is used for containerization. What is the meaning of containerization? Containerization means package our application code and required dependencies as a single unit for the execution. Okay. So here, when it comes to the Docker, so we are responsible to create the Docker image. Once the Docker image is created, we can run that Docker image in any computer. Once the Docker image is created, we can run the Docker image in any computer without bothering about required softwares. Okay, now my application should be deployed into 20 environments. What I need to do? My application should be deployed into 20 environments, guys. What should I do? To deploy my application into 20 environments, what I should do? Do I need to install the softwares in all the 20 computers? Or I just need to take the Docker image and execute the Docker image? Do I need to install the required softwares in all the 20 computers, or just to take the Docker image and run the Docker image? Come on, guys. Just to take the Docker image and run the Docker image. So whenever you run the Docker image, Docker container will be created. What the Docker container will do? Docker container will run our application with required dependencies. So our application deployment process simplified with the Docker. So now you need to understand life without Docker and life with Docker. You need to understand life without Docker and life with Docker. What is our life without Docker as a software engineer? Guys, what is our life as a software engineer if there is no Docker? If there is no Docker, then what is our life? Life without Docker for the software engineer, we will end up with a lot of environmental issues. We will end up with a lot of environmental issues. So if we have Docker, happily we can deploy our application in any computer without bothering about required dependencies. When I say dependencies, here the softwares that are required to run our application. We can run our application in any environment without bothering about the required dependencies. Are you clear? Now we need to understand the Docker architecture. Sir, how Docker will know what softwares are required to run our application? Okay. And if I want to change a version, suppose now Java 17 is available. Now I want to upgrade my project to Java 21. I want to upgrade my project from Angular 13 to Angular 14. Okay. How the version updates can be done by using Docker, and how Docker will understand what are the dependencies that are required for our application. So we need to understand Docker architecture. Okay. Once we understand the Docker architecture, then I will go for a Docker setup in our machine and I will show you practical examples on the Docker. Then definitely you will enjoy with the Docker workshop today. I'm not going to waste your weekend, guys. So Sunday, it's very valuable for the working people. So I'm not going to waste your time. So I will give you the very, very, very valuable content as part of today's workshop. Definitely you will feel happy for joining today's workshop. The 2 hours of time that you are going to spend with me today, it's very, very valuable for you. Got my point? So I respect your time. Yeah, I'm not going to waste that. So the only thing is, so give me some time. So definitely I will make this workshop beautiful. I hope you understood the last 1 hour, whatever we spent. So it's useful. You feel, if you are feeling that you are learning something, then that's good. You can stay for another 1 hour with me to understand. If you feel the last 1 hour, almost 1 hour completed, if you feel the last 1 hour is useful, then the next 1 hour is better than the last 1 hour, because practicals we are going to do. People watching from YouTube, almost 100 people are watching, but no likes for the video. So if you give the likes, I will get more encouragement to do more workshops like this. People watching from YouTube, so please like this video and give me a comment. So please give encouragement. If you give the likes, then I will understand that you are also enjoying this class. All good, guys. So now let's understand Docker architecture. So Docker, technically, we need to understand how Docker is going to work, what is the Docker terminology, and how to Dockerize our applications. Got it? So Docker is a free and open source software that is used for containerization. You got the clarity? What is the containerization? Containerization means package our application code plus required dependencies as a single unit for execution. So if we use a Docker in the project, we can run our application in any machine without bothering about the softwares. Okay. If we use Docker in our project, then we can run our project in any system without bothering about underlying softwares. Okay, what softwares are available in that? Which version of the software is available? Which OS is available? Okay, we no need to bother about anything. You just take the Docker image and you run your application in any computer. Docker is going to take care of all the required setup, right? Docker is free and open source. It is used for containerization. Containerization means package our application code plus required dependencies as single unit for execution. That single unit is called as a Docker image. Okay. Once the Docker image is created for our application, we can run that Docker image in any system. By using the Docker image, we can run our application in any system without bothering about underlying softwares. Okay, good. So Docker architecture, guys. Let's understand Docker architecture. Good. Let's understand Docker architecture. So when we are talking about the Docker architecture, first we need to understand Dockerfile. Then we need to understand Docker image. Then Docker registry. Then Docker container. Okay. To understand the working process of the Docker, so we need to discuss about these four concepts. First one is Dockerfile. Second one is Docker image. Third one is Docker registry. And fourth one is Docker container. Now, so see here, when we want to Dockerize any application, here our application code will be available. Okay, application code will be available. Developers are going to write the code required for the application. Application code will be available. So this application code we can't execute in any computer because for every application some technical stack dependencies will be available. So this application front-end technology, back-end technology, database server. So if those dependencies are available, then only we can run our application. Now, what are the dependencies to run this application? Those dependencies we are going to specify inside one file that is called as Dockerfile. So what is this Dockerfile? Dockerfile is used to specify the required dependencies to run our application. We are saying that Docker is used for containerization. By using Docker, we can run our application in any machine without bothering about the required softwares, right? How Docker will know what softwares are required for my application? That's where Dockerfile comes into picture. So Dockerfile is used to specify the instructions for the Docker. What dependencies are required? I want a Linux machine to run my application. In the Linux machine, I want Java 17 version. I want MySQL database 8.5. I want Tomcat 9.0. I want Angular 13. So those are the dependencies that are required for our application. What dependencies are required to run our application? Those dependencies information we are going to provide to the Docker by using Dockerfile. We are going to provide that information to the Docker by using Dockerfile. Once the Dockerfile is available, by using the Dockerfile, we are going to create Docker image. Once the Dockerfile is ready, so in some projects, developers will write the Dockerfile. In some projects, DevOps engineers are going to write the Dockerfile. But in my point of view, both developers and the DevOps people also should know Dockerfile creation. How to write the Dockerfile, how to specify what instructions that are required to write the Dockerfile. Okay, so Dockerfile is very, very important when we are working with the Docker, guys. Without a Dockerfile, we can't use this Docker. Got my point? Dockerfile is used to specify instructions required for our application. Okay, by using the Dockerfile, we are going to build Docker image. Once the Docker file is available, we need to create the Docker file. I will tell you how to write that also. We are going to write a Docker file. Once we write the Docker file, by using the Docker file, we are going to create a Docker image. Our application code and required dependencies. Where is our application code? So my Java application is available. That is packaged as a jar file or war file. So where is that code? Where is the application code available? And to run that application code, what dependencies are required? We are going to mention in the Docker file. Once the Docker file is ready, by using the Docker file, we are going to build Docker image. We are going to build the Docker image. Once the Docker image is created, that Docker image we can store into Docker Hub, guys. That is called a Docker Registry. So whatever the Docker image I have created, I want to use this Docker image in future. I want to use this Docker image. I want to execute this Docker image in multiple systems. So for that, what we will do, we can store the Docker image into Docker Hub. This is called push operation. So this is called as a push operation. Whatever the Docker image is created, we will push that Docker image into Docker Hub. So Docker Hub is called as a Docker registry. Some people will use Docker Hub to store the Docker images. Some people will use JFrog repositories, Nexus repositories, AWS ECR, Elastic Container Registries. There are multiple places where we can store our Docker images for future purpose. We can store the Docker image into Docker Hub. Docker Hub is called as a Docker registry where we can store the Docker images. Today I have created a Docker image. I want to use that image in the future. I want to use that image in multiple systems. So that's why we are going to store the Docker image into Docker Hub. So it's not mandatory that we should use only Docker Hub. What are the alternatives available for the Docker Hub? You can use Nexus repository. You can use JFrog repository. You can use AWS ECR also to store the Docker images. You can store the Docker image into Nexus repository. You can store into JFrog repository. You can store into AWS ECR, or you can store into Docker Hub. So in this workshop, I will show you how to store Docker image into Docker Hub, guys. So what is a Docker Hub? It is a registry where we can store our images. Okay. So once the Docker image is created and stored in the Docker Hub, so this image, whatever we are storing in the Docker Hub, right? We can make it as a public image or private image. If it is a public image, anybody can take the image, they can run our application. Now, our application code and application dependencies will be packaged as a single unit for execution. That single unit is called as a Docker image. Are you getting my point? What is a Docker file? Docker file contains a set of instructions to specify what dependencies are required to execute our application. Docker file contains set of instructions to Dockerize our application. So basically, we'll specify what dependencies that are required to run our application. So Docker file is basically used to specify what dependencies that are required to run our application. So we are understanding Docker architecture. Are you guys clear as of now? Are you guys clear as of now? What is a Docker file? What is the Docker image? And what is Docker Hub? Our application code will be available. To run that code, some dependencies are required. What dependencies are required, we will specify in the Docker file. By using the Docker file, we are going to create a Docker image. Docker image contains code plus dependencies. Dependencies nothing but software. Once the Docker image got created, we can store the Docker image into Docker Hub. Docker Hub is called Docker registry, where we can store our Docker images. What are the alternatives? What are the alternatives for the Docker Hub, guys? Can you tell me? What are the alternatives for the Docker Hub? Can anyone tell me? Instead of storing Docker images in the Docker Hub, what are the alternatives available for that? What are the alternatives available for that? What are the alternatives available for that? Not GitHub. Docker image we can't store in the GitHub. GitHub is used to store the project code. GitHub is used to store the project source code, but not Docker images. Okay, we have Nexus repository. We have Nexus repository. We have JFrog repositories. Nexus repository available. JFrog repository is available. And AWS ECR is available to store the images. Got it. Now, once this Docker image got created, we can pull the Docker image and we can run the Docker image. You can run the Docker image in multiple computers. Okay. So this is computer 1 where I can run my Docker image. So like this, once the Docker image got created, you can take the Docker image and you can run the Docker image in multiple systems. You can pull the image and you can run the image in any system. So whenever you run the Docker image, it is going to create. Whenever you run the Docker image, it is going to create Docker container. Whenever you run the Docker image, it is going to create a Docker container. Now this process is called run. Run the Docker image. So in which computer you want to execute your application? In that computer, you pull the Docker image. That means you pull the Docker image and you run the Docker image. Okay. So in whichever the computer you want to run your application, so you just need to pull the Docker image and you need to run the Docker image. So when you run the Docker image, what will happen? When you run the Docker image, it is going to create a Docker container. When you run the Docker image, it is going to create a Docker container. So what is the meaning of Docker container? Docker container is going to run our application. Okay. So code and dependencies are available, right? So those things are going to run. So once the image is created, we can run multiple containers. Once the Docker image is created, we can create multiple containers and we can run our application. So I have some dev environment. Okay. And I'm having some sit environment. Dev environment is available and I'm having sit environment. My dev environment and my sit environment is available. I can take this Docker image and I can run this Docker image. So wherever I want, I can run my Docker image. Dev environment and sit environment. Then next one, similarly, UAT environment or pilot or prod. Wherever you want to run your application, you just need to take the Docker image and you need to run the Docker image. This is called as Docker architecture. This is called Docker architecture. Are you guys clear with the Docker architecture? What is a Dockerfile? Dockerfile is used to specify instructions to Dockerize our application. So where is the code? What dependencies are required? That we are going to specify. Now tomorrow, when I want to change any Java version or Angular version, do I need to change everywhere or I just need to change in the Dockerfile? I want to change from Java 17 to Java 21. Where I need to change that, guys? Where I need to change that? I want to change the Java version. Where I need to change that? Do I need to change in all the systems? Do I need to change that in all the systems? Not required, right? I will change in the Docker file and I will create the Docker image. So whenever code changed and whenever your version changed, you need to recreate the Docker image and you need to rerun the Docker image. That's it. You need to recreate the Docker image. Suppose I specified that I want Java 17. Now today I want Java 21. Then I will change my Docker file. I will change the instruction in the Docker file. I will rebuild my Docker image. Then I will rerun my Docker image. When I run my Docker image, Docker container will be created. So where our application code and application dependencies will be available, guys? Where our application code and application dependencies will be available? Application code and dependencies will be packaged as a single unit. What is that single unit is called? What is that single unit is called? Application dependencies and application packages will be available. Application code and dependencies will be available as a single unit. What is that single unit is called? What is that single unit is called? That single unit is called as Docker image. Docker image. To create the Docker image, what is required? To create the Docker image, what is required? To create the Docker image, what is required? To create the Docker image, we need a Dockerfile. And where we can store the Docker images? Where we can store the Docker images? Docker images we can store in the Docker registry. We can use a Docker Hub to store our Docker images. Okay. And once the Docker image is available, you can take that image and you can run that image in any system. When you run the Docker image, Docker container will be created. When you run the Docker image, Docker container will be created. Okay. So inside the Docker container, our application is going to execute. Inside the Docker container, our application is going to execute. Now, the only thing that you need to do is, in order to run Docker image in any system, we need to install Docker software. Install Docker. Okay. So if you want to run the Docker image, you need to install the Docker software in any machine. So now I want to run my Docker image in the dev environment. So to run the Docker image, you need to install the Docker software, then you can run the image. Now I have 30 environments for my project. So in the 30 environments, I want to run my application. What I need to do? Just install the Docker, then pull the Docker image, download the Docker image, and run the Docker image. That's it. That's it. So tomorrow, if I want to change some code, if I want to change some dependencies, I will edit my Dockerfile. I will recreate the Docker image. Then I will rerun the Docker image. When I run the Docker image, Docker container will be created. Guys, now I have a question. Once I create the Docker image, once I created the Docker image, using that image, can I run my application in multiple computers? Using the Docker image, can I run my application in multiple computers? Yes, you can take that image and you can run that image. But what is required to run the Docker? What is required to run the Docker image in your system? What is required to run the Docker image in your system? Docker software. You just need to install the Docker software, then you can run the Docker image. When you run the Docker image, what will happen? Docker container will be created. What is Docker container? Inside the Docker container, our application is going to execute. Now, if you see the official logo of the Docker, it is a ship symbol with boxes. Why they have given ship with boxes? These boxes are called as containers. Easily we can transfer our containers from one place to another place. That means Docker images, Docker containers are easily shippable. Symbolically, they are representing in the logo. This is the logo of the Docker. So the Docker logo is a ship with containers. So that means easily we can ship our containers. Easily we can run our containers in any machine. Easily we can transfer them. So Docker is platform independent. You can run the Docker image in the Windows machine. You can run the Docker image in the Linux machine also. Docker containers we can execute in the Windows as well as in the Linux also. There is no restriction. There is no restriction. Docker is platform independent. Why it is a ship with boxes? The logo, ship with boxes, easily transferable. Easily transferable. Good. So we understood Docker architecture. What is a Dockerfile? It contains a set of instructions to Dockerize our application. It contains a set of instructions to build a Docker image. Where is the code? What are the dependencies? Where is the code? What are the dependencies required to run that code? We are going to specify by using Dockerfile. It contains a set of instructions to build the Docker image. And next one is Docker image. It is a package. It is a package which contains code plus dependencies. So what is the code and what are the dependencies that are required will be part of Docker image. To create the Docker image, Dockerfile is required. Dockerfile contains a set of instructions to build the Docker image. Docker image is a package which contains code plus dependencies. Docker registry. It is a place where we can store our Docker images. Docker Hub or Docker registry. It is a place where we can store our Docker images. For example, Docker Hub is a registry where we can store Docker images. Docker container. Okay. When we run the Docker image, then Docker container will be created. When we run the Docker image, then Docker container will be created. Our application will execute inside Docker container. Our application will execute inside Docker container. Okay, guys. So this is about Docker architecture. Guys, Docker internally uses virtualization, guys. Docker internally uses virtualization. Sir, what is that Docker virtualization? Now, here my Docker image is available. So assume that this is my Docker image. When we run the Docker image, what is going to happen? That is very important to understand. Okay? So Docker containers will use virtualization concept. What is the meaning of that virtualization? So here I have a computer. So assume that this is my machine. This is my machine. It can be a Windows machine or it can be a Linux machine. In my machine, I'm having host OS. Okay, this is my Windows. I'm using Windows in my laptop. Okay, so Windows OS is my main operating system. This is my host operating system. I have a computer. To use a computer, operating system is mandatory. Okay, so this Docker image is available in the Docker Hub. Assume that. So this is our Docker Hub. Inside the Docker Hub, Docker image is available. That is Java application Docker image. Now, by using this Docker image, I want to run my application. Application code plus application dependencies are available in the Docker image. The Docker image is stored in the Docker Hub. Now, I have my computer, my laptop is there. In my laptop, I need to run this Docker image. Okay, so in my computer, one operating system is available. That operating system is called host operating system. So in this host operating system, to run the Docker image, what we need to do? We need to install Docker engine. So in order to run the Docker images, first you need to install Docker engine. So Docker engine is nothing but Docker software. In order to run a Docker image in our system, you need to install Docker engine. Once we install the Docker engine, then we can pull the Docker image and we can run the Docker image. Pull means download, run means execute. Okay, pull means downloading the Docker image. Once the Docker image is downloaded to our system, then we can run the Docker image. When we run the Docker image, then Docker container will be created. Whenever we run the image, Docker container will be created. Let me call it as a C1, container 1. When I run the same image again, or a different image, okay, then another container will be created. This is called container 2. When I run the one more image, then what will happen? Another container will be created. Like this, in one machine, can I run multiple containers? In one machine, can I run multiple containers, guys? Yes, that is possible. So same image you can run multiple times so that 3 containers will be created, or you can run 3 different images, then 3 different containers will be created. Okay, so what is this container? This container is a Linux virtual machine. Okay, so our application will run in the different machine. It is independent from our host operating system. So my machine is available. My machine is having Windows operating system. In my machine, no Java, no Angular, no Tomcat, no MySQL database. But still, I can run the application as a Docker image. Inside the Docker image, code is available. Required dependencies are available. What I will do, I want to run this Docker image in my system. Then I'm going to install Docker software in my system. Only Docker I will install. That's it. I will not install Java. I will not install Python. I will not install Tomcat, database, Angular, nothing. So my machine is just a machine with only operating system. In this machine, I will install the Docker software. Okay. Once the Docker software is installed in my system, then I can pull the Docker image. Pulling the Docker image, nothing but downloading the Docker image. Okay. So I can, once the Docker is installed in my system, I can create the image in the same system, or I can pull the images which are already available. I can pull the Docker image and I can run the Docker image. When I run the Docker image, what will happen? It will spin up a virtual machine in our operating system. That is called virtualization. Docker internally uses virtualization concept. So every container is a Linux machine, guys. Every Docker container that you are creating is a Linux virtual machine, where the required softwares will be available. So in our machine, one container will create. Container is one virtual machine. Inside that container machine, we can see that container machine. Practically, I will show you that also. So one virtual machine will be created. Inside that virtual machine, our code will be copied, the softwares will be installed, and our application will be executed. Okay. So in our machine, container will be created. Container is a virtual machine. Are you guys getting my point? Are you guys getting my point? How the Docker is going to manage the softwares? And what is a container? So in the layman terminology, container means one virtual box. You can say one virtual machine. If I run the image for 3 times, then what will happen? 3 containers will be created. So 3 containers means 3 virtual machines will be created on the fly. When you delete the container, that virtual machine will be deleted. When you delete the container, that virtual machine will be deleted. Okay. So can I say Docker is containerization software based on the virtualization concept? Come on, guys. Can I say Docker is a containerization software working based on the virtualization? Yes. What is the meaning of virtualization? What is the meaning of virtualization? Running one machine in another machine. Running one operating system in the another operating system is called as a virtualization. Docker will internally use that virtualization to create the containers. Container means what? It is a box. Okay. So inside that virtual machine, what will be available? What softwares will be available in the virtual machine? Guys, what softwares will be available inside the virtual machine? The required softwares to run our application. Okay. The virtual machine contains the required softwares to run our application. How this virtual machine will know what softwares are required? They are already mentioned as part of image. How that image is created? That image is created by using Dockerfile. What will be there in the Dockerfile? Set of instructions to build the Docker image. You got it? You got it? What is a container? Come on. With one image, we can create any number of containers. There is no limit. With one image, we can create any number of containers. With one image, we can create any number of containers. Container means virtual box. Container means virtual box. Got it? So containers are created based on virtualization. Containers created based on virtualization. So in one machine, we are going to run other machine. Okay. The host machine, virtual machine, both are independent. So you don't need to install any software in the host machine because Docker will take care of the softwares in the virtual machine. Every container is a virtual machine. Are you clear? Yeah. Docker. Docker is a containerization software. Docker is a containerization software. What is the meaning of containerization? Packaging the application and application code as a single unit for the execution is called as a containerization. So what is the benefit with the containerization? If you use the containerization, then we can run our application in any system without bothering about underlying softwares. Docker architecture. So Dockerfile. Dockerfile contains set of instructions to build Docker image. Okay. So when you are working with the Dockerfile is very important. Dockerfile contains set of instructions to build Docker image. Then what is a Docker image? Docker image is a package which contains code plus dependencies. Docker registry. It is a place where we can store the Docker images. Docker container. When we run the Docker image, then Docker container will be created. Our application will execute inside a Docker container. Every Docker container is one virtual machine. Every Docker container is one virtual machine, which will be created on the host machine. Every Docker container is one virtual machine, which will be created on the host machine. Okay. In order to work with the Docker, then we need to do Docker setup. Okay. Guys, today I'm going to show you Docker setup in the Linux machine. I will take one Linux machine in the AWS cloud and I will do the setup, because in the real time, we will use Linux boxes to perform our application deployment operations. You can install the Docker in the Windows also, but in the real time, we don't use Docker in the Windows. We are going to use the Docker in the Linux machines. Okay, good. Clear. Let me go to Docker setup. So to do the Docker setup, I'm using my AWS account. In the AWS account, every developer should have AWS account. Cloud is very important nowadays. You need to explore the cloud. If you are new to the AWS part, guys, so I have done one crash course on the AWS. Within 30 minutes, you can understand what is AWS. Within 30 minutes, you can understand what is AWS, how to create the account in the AWS, how to practice that. I have done one AWS tutorial, AWS cloud tutorial. So 3 months back, I uploaded one video. So here I explained what is AWS, how to create the account in the AWS, okay, how to create virtual machines in the AWS cloud. So anyone who want to explore the cloud is the future for the software, guys. So it's very, very important. So I have shared that video in the chat box and I will share that in the WhatsApp group also. So just go through that video. So in that video, you will understand several important topics. What is cloud? How to work with AWS cloud? How to create account in the AWS cloud? These are the things I explained in this tutorial. Within 30 minutes, you can understand what is cloud, why, what is AWS, what services available, how to set up the account, how to create virtual machine, how to do the database setup in the cloud, how to do website hosting in the cloud, how to do the domain mapping in the cloud. These topics I explained within 30 minutes, the basic cloud information. It's very, very important for everyone to know about the cloud. Good. So after the session, I will share this video as well. Please go through that. Now, I want to do the Docker setup. Okay. So to do the Docker setup, set of steps I have given in my GitHub repository. So Docker setup is available. In the GitHub, I have given this Docker setup document. So log in into AWS cloud account and create one virtual machine and connect to that virtual machine using Mobile Extra. Then by using these commands, we can install the Docker software and we can verify Docker is installed or not. First, let me complete the step 1. Set up Linux machine in the AWS and connect to that machine using Mobile Extra. Good. Go to EC2. EC2 is a service in the AWS cloud, which is used to create virtual machines. Good. I'm trying to log in into my AWS account. Good. I logged into AWS cloud account. So currently you can see in the AWS cloud, I'm operating from the Mumbai region. Currently, I don't have any instances. Instances count is 0. Let me go and click on launch instance. So I'm giving this as Docker VM. I'm taking one virtual machine with Linux operating system. For that, I'm giving the name as Docker VM. I'm creating this machine by using Amazon Linux AMI. What is AMI and all? You can see in that AWS video, guys. T2 Micro I'm using, which is free tier eligible. This machine is free of cost for 1 year. Key pair. So I don't have any key pair. Let me create a new key pair. I'm creating the key pair as Docker Workshop key pair. In order to connect with the machine, this key pair is required. Click on create key pair. When I click on the create key pair, that key pair is downloaded into my system. So that key pair is used to connect with that machine. Okay, Docker workshop key pair I have created. Default VPC we are using. Security group, I'm going with existing security group. Then that's it. So I am taking one virtual machine. AMI is Amazon Linux and T2 micro instance. One key pair I have created just now. No need to change any network. Default VPC. Security group I'm selecting existing. If you want, you can create the new security group. Then simply click on launch instance. With this, my machine will be launched. Successfully initiated the launch of the instance. One virtual machine I have created in the AWS cloud. So we need to wait till that machine turns into running state. Still it is in the pending state. The machine will come into running state. Once the machine is in the running state, then we can connect to this machine by using Mobile Extram or by using Putty. In the video, I have explained that part also, how to connect with the Linux machine by using Mobile Extram. Let me refresh. Yes, my machine is started. It is in the running state. For this machine, public IP will be available. Copy this public IP and connect with the machine. So I'm using Mobile Extram software. It is also free to connect with the Linux machines. Go to Mobile Extram session. Linux machines works based on SSH connection. Click on SSH, remote host. I'm giving my public IP. My machine username is default username EC2 user. Password will not be available. Private key will be available. We have selected PEM file. Select that PEM file. Okay. So go to this PC downloads. In the downloads, I have that PEM file. Just now we created a PEM file. Select that PEM file. Click on OK. So with this, I'm able to connect with my Linux machine successfully. Now you can check it. Who am I? I connected as a EC2 user. Good. Next, we need to install the Docker. Before that, let me check Docker-v. What it is saying, guys? When I use Docker-v, it is saying Docker command not found. So in this machine, Docker software is not available. Just I completed step 1. That means I created a Linux machine and I connected to that Linux machine using Mobile Extram. Now I want to install Docker in the Linux machine. So for this, the commands are available here. So just copy these commands and execute. Sudo yum update. It is used to update the existing packages. Nothing to do because it is the latest machine. All the packages are up to date. So this is the command which is used to install the Docker. Sudo yum install Docker-y. It is going to install Docker software in this Linux machine. Why we are installing the Docker software? To create the images, to run the images, Docker software is required. Docker installation got completed. Then let's start the Docker as a service. Sudo service Docker start. So Docker start created, Docker start is done. Then after, very important step, guys, we install the Docker. Now we connected to this machine as a EC2 user. Now Docker is installed. When the Docker is installed, Docker group will be created. So now I want to perform operations in this machine as a EC2 user. So that's why we are going to add this EC2 user to Docker group. It is a user mode command in the Linux, which is used to add this user to Docker group. When you install the Docker, Docker group will be created, but we want to perform the operations as EC2 user in the Linux machine. So that's why I'm adding EC2 user to Docker group so that we can perform Docker operations. Okay. Once we add the EC2 user to the Docker group, just type exit. Just close the session and reconnect to that session. I have given exit. Then press R to restart the session. Once the session is restarted, then you can execute Docker-v. Now you can see Docker version 24.0.5 is created. Okay. So with this, Docker setup got complete. So in my Linux machine, Docker setup got completed. So we can verify the Docker info. When you execute Docker info, it will show you the information. Currently, how many containers are available? 0. Docker client is installed and debug mode false. Containers 0. Images 0. Okay. Currently, nothing is available. It is a brand new machine in this machine, we have installed Docker. Okay. Now, in order to work with the Docker, we need to know some Docker commands. Okay. Docker setup, I have given a Git repository, guys. So let me share the Git repository link here. In the notes, I'm giving this Git repository. So when you access this URL in the browser, then you can see the steps. Okay. So this is the Git repository link to set up the Docker in your system. Once the Docker setup got completed, then in order to work with the Docker, we need to use some Docker commands. We need to use some Docker commands. Sir, what are the commands? The first one is Docker images. The first command is Docker images. To display list of Docker images available in our system. Okay. Docker ps to display list of Docker containers running in our system. Okay. Docker images is a command. It is used to display the images which are available in our system. Docker ps to display list of Docker containers running in our system. So let me go and execute a command called Docker images. Now, when I execute Docker images, is there any image available in our system? Guys, please involve for the next 30 minutes practicals. Very, 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 very important. People from YouTube, are you able to follow? Are you able to follow? From the Zoom, guys, able to understand? It's very, 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 very important workshop and very useful. You are getting for free of cost. Please be active for the next 30 minutes because practicals we are doing on the Docker. Theoretically, we understood. We got the clarity. Now practicals also, if we understood, then happily you can keep Docker in your resume. Got it. So I want to check what are the Docker images available in my system. I have taken a Linux machine. So in this Linux machine, I have installed Docker software. I have taken a Linux machine. In this machine, I have installed Docker software. Now, in order to work with the Docker, we are using Docker images. Okay. Docker images is a command. What is the purpose of the Docker images command? It will display what are the images available in our system. Currently, is there any image available or there is no image available in our system? Currently, any image available? There is no image available in our system. Currently, there is no image available in our system. Okay. Can we check any container is running in our system? Docker ps. Now, any container is available in our system? No container is available in our system. So now what we need to do? Now what we need to do, guys? We need to download the image and we need to run the image. We need to download the image and we need to run the image. In order to download any image, okay? So here you can use a command called Docker pull command with the image name or image ID. Image ID or image name you can use to download Docker image. Docker pull image name or image ID. Then Docker run, you can use image ID or image name to run Docker image. Container creation. So whenever you want to download any Docker image, you can go for Docker pull command. So Docker pull command, you can pass Docker pull command with image ID or image name. So it is going to download a Docker image. Once the Docker image is downloaded, you can run the Docker image. Whenever you run the Docker image, it is going to create a Docker container. Okay. So if you want to stop, if you want to delete the image, Docker RMI image ID or name. So when you give image ID or name for the RMI command to delete Docker image. Okay. To delete the Docker image, you can go for that. Docker RM container ID. Okay. To delete Docker container. Like this, there are several commands available on the Docker. Okay. Right. Docker images, Docker ps, Docker pull, Docker run, Docker RMI, Docker RM. Okay. Now, sir, where we can find the Docker images? Where we can find the Docker images? That's where Docker Hub is available. You can go to Docker Hub in order to understand the Docker image names, image IDs. So everyone can create the account in the Docker Hub. So Docker Hub is available where you can find the images. For example, I want to run MySQL database. What is the image name for that? You can find out in the Docker Hub. Login.docker.com. It is a Docker Hub. If you don't have an account, you can sign up. So my username and my password. I have already account in the Docker Hub. So as part of our batches, we are using Docker in our Spring Boot and project batches in the DevOps. So we are using Docker. So I already created an account in the Docker Hub and I stored lot of images in the Docker Hub. So you see one of my image I created for Spring Boot image. You see how many people downloaded my Docker image? 67,000 people downloaded my Docker image. So once I create the Docker image and upload in the Docker Hub, anyone can pull my Docker image and they can run my Docker image. So this is a Spring Boot application REST API. So they are pulling my Docker image. 67,000 people pulled my Docker image because it is a public image and they are running my Docker image. So this is the name of my Docker image. 2 years ago, I pushed this Docker image into Docker Hub. As of now, these many people pulled my Docker image and they are using my Docker image. Okay, good. So this is my Docker Hub account. All these are my Docker images which I have stored. So I have stored one Java web application image. 3,500 people pulled that. Similarly, I have stored Python images, Angular images, Python Flask application I have stored here. So many Docker images I have in my Docker Hub account. Got it? Fine, that's fine. So here I want to search for the Docker images. Okay, so you need to create the account and log in into Docker Hub, search for the Docker Hub. You can search for the image. I want to go with first Hello World Docker image, just a basic application. Okay, so there is a Docker image with a name called Hello World. Okay, so 1 billion people, 1 billion people downloaded this Docker image. This is official Docker image. Okay, you can create the Docker image for your application and Docker is providing some predefined images also. You can create your own image and you can pull the Docker images which are already available. Okay, so go to Hello World image. What is the name of the image? Hello World. They are giving the syntax also. Docker pull Hello World. What is a Docker pull? Docker pull is a command which is used to download the image. What is the name of the image? Hello World. You just copy this, then go here. Before I am going to execute this command, let me show you Docker images. Nothing is available. Now I am using Docker pull Hello World. Now enter. It is going to download an image with a name called Hello World. Now you see Docker pull Hello World image I have downloaded. Using the default tag pulling from the library and pull completed status, downloaded a new image for the Hello World. So from the docker.io.library, it pulled Hello World image. After pulling the image, you can check Docker images. Now you see there is an image with a name called Hello World. This is image ID. 5 months ago, this is created and size is 13 KB. I have the Docker image. Once the Docker image is available, can we run the Docker image, guys? Once the Docker image is available, can we run the Docker image? What is the command to run the Docker image? Docker run image ID or image name. You check it. Docker run Hello World. That is the name of the image. Image name. Docker pull to download the image. Docker run to run the image. When you run the image, what will happen? Docker container will be created. Okay. Hello World is just a basic image which will give you Hello World message. Enter. Right. So when I execute Docker run Hello World, it is giving a message hello from Docker. That means that image is executed, container created, and a container has given a message. This message shows that your installation appears to be working correctly, boss. Your Docker setup is successful in the system and you are able to run the Docker image and you are able to create the Docker container. So how it is working in the background? They have given some steps. Could you please read these 4 points? You will understand what happened in the background. Could you please read these steps so that you can understand what happened in the background? Come on, guys. You understood what happened in the background? The Docker client. So in our machine, we have installed Docker, right? In our machine, we have installed Docker. So what happened? Docker engine is available. So that is going to install Docker client. Okay. So once we install the Docker client will be available. Docker client contacted the Docker daemon. Docker daemon is a background process that is available in our system. The Docker daemon pulled the hello world image from the Docker hub. The Docker daemon created a container from the image, which producing the output. Docker daemon, that means whenever you execute any Docker command, Docker client will contact the Docker daemon. Docker daemon is a background thread, which is going to do all the Docker operations. Okay, good. So you got the concept how to check the images, Docker images. There is one image available. Docker PS, no containers are running. Docker PS-A, it will display the containers which are stopped also. Docker images command will display what all the Docker images are available. Docker PS command will display the containers which are in the running state. Okay. The Docker PS-A, it will display the containers which are running as well as stopped. So there is a container which is stopped, exited, status is exited. So whenever I execute Docker run hello world, it is a standalone application image. Okay, it is just producing hello from Docker, then it is stopping the container. Right. So how to check the containers which are stopped? By using Docker PS-A. Okay, see here, I executed image for 2 times. So container created 2 times and it got stopped. One container stopped 3 minutes ago. Another container stopped 11 seconds ago. 2 times I have created that image. Okay. Good. Now, how to delete the container, guys? How to delete the container? Docker RM container ID. Docker RM container ID. Okay. So it is used to delete the container which is in the stopped state. Now, I have deleted the container. Docker PS-A. All the containers got deleted. Now, Docker images available. So Docker images, there is one image available. How to delete the image? Docker RMI, image name or image ID. Anything is fine. I have deleted my Docker image. RM command to delete the container with the container ID. RMI command to delete the image with the image ID. Okay. So now you see Docker images. Everything is clean in my system. Nothing is available. I pulled one image, I executed that image, container got created. Now I stopped it. Okay. I deleted the container and I deleted the image also. Are you able to follow me? What are the commands that we used as of now? Docker images command to display list of Docker images available in our system. Docker PS to display list of containers running in our system. Docker pull command to download a Docker image. Docker run command to run the Docker image. Docker RMI command to delete the Docker image. Docker RM command to delete a Docker container. Are you clear? Now, sir, why this container got stopped? That is hello world image now. That's why it got stopped. Okay. If you run any web application, that container will not be stopped. Whenever you run any web application image, that container will not be stopped. It is hello world is a basic image. Okay. And one more thing that we need to understand here. Earlier I used Docker pull hello world. Then after I executed by using Docker run hello world. Instead of this pull command, directly I will use Docker run hello world. But currently in my system, Docker image hello world is available or image hello world is not available. Guys, in my system, Docker image is available, hello world are not available. It's not available. Then what will happen when I execute this run command? Then what will happen when I execute this run command, guys? What will happen when I execute this run command? Image not found, or it will pull and run the image. You need to understand, Docker is intelligent here, guys. Docker is intelligent here. Whenever you execute run with image name, first it will check for the image in the local. Unable to find the image locally. Whenever you execute Docker run hello world, unable to find image locally. First it is giving the priority for the local images. If the image is available in the local, then it will pull that image and it will run that image. So if first it is checking in the local, if the image available in the local, it will use that image and it will create the container. But in this scenario, the image is not available in the local. So that's why it is going to download that image. Then it is going to run the image. So do we need to pull? Is it mandatory to pull to run, or directly you can run also? Now you can tell me, is it mandatory to pull the image to run, or directly we can execute run command? It's not mandatory to pull. Directly we can execute. When we execute directly, then what is happening? When we execute directly, then what is happening? It is checking in the local. It is checking in the local. If available, run. If not available, then pull and run. You got it? Got my point? Okay, very good. So now, Docker images available. One image is available, and Docker ps-a. Container is in the running state, or container is in the stopped state? Container is in the running state, or container is in the stopped state? In the stopped state. Okay. Can we delete the container which is in the stopped state? Yes, we can delete it. What is the command? Docker rm container id. What is the command to delete the image? RMI. Here we can do one more thing. Docker system prune -a. When I execute Docker system prune -a, all stopped containers, unused images will be deleted. In the single shot, I want to clean up my system. All stopped containers, all unused images, I want to delete. Docker system prune -a. So this will delete all stopped containers, all networks, all images without any container association will be deleted. Yes. Yes. So now see, 13 KB space reclaimed. So it deleted stopped containers and unused images. Docker system prune -a, which is used to clean up our Docker server. Okay. Delete, clean up. Clean up. I mean, it is going to delete stopped containers and unused images. If your image is not associated with any container, then that will be deleted. Let me save this file, guys. So after the class, I will share this notes. Okay. So I have shared the WhatsApp group link, right? In that WhatsApp group, you will get this notes. Okay. Good. Yeah. So you understand what is the purpose of Docker system prune -a? Guys, you understood what is the purpose of Docker system prune -a? What is the purpose of Docker system prune -a? To delete all the stopped containers and unused images. To delete all the stopped containers and unused images, we are going to do this. For YouTube viewers also, I'm going to share WhatsApp group link in the live chat. You can check that and you can join. The people who are watching in the live, you will get that in the chat box. Okay, 1 minute. After the class, these notes and this video, you will get it. Yeah. For the live people in the live chat, the people who are watching from YouTube, I have given WhatsApp group link in the live chat box. You can join in that so that you will also get the notes and document. Okay, good. Fine. So we understood the Docker commands. Now, for example, I want to run a Docker container for the image which is already available. So we want to understand how to run the existing Docker images and how to create a Docker image for our application. Both we are going to understand. Okay. So both we are going to understand. Perfect. Now here, if you observe, I have shown you one of my famous Docker image, which is Spring Boot REST API. Okay. So Spring Boot REST API is available. I want to take this image and I want to run this image. Okay. So what is the command? Docker pull image name. So this is the command in order to run this Docker image. Ashok IT / Spring Boot REST API. This is my Docker image. So I can first pull this image and I can run this image. Instead of pulling, can we run directly also? Guys, instead of pulling, can we run directly also? Is pull mandatory? Is pull mandatory or is pull optional? Is pull mandatory or is pull is optional? Optional, right? Directly you can execute run command. But here let me show you how to pull this. Clear. Currently in my system, no images are available. No images are available. And can you check, is Java installed in my system? Guys, is Java installed in my system or Java is not installed in my system? Java is not available. Spring Boot application is a Java-based application. To run the Spring Boot application, Java is required. But do I need to install the Java to run my Spring Boot application here, which is available as a Docker image? Not required, right? Not required, right? So just to pull the image, Docker pull Ashok IT Spring Boot REST API. This is my image name. Ashok IT / Spring Boot REST API. Execute. It is going to run a Docker image. It is going to pull the Docker image, guys. Yes, the Docker image is downloaded from Docker Hub. You can also pull my Docker image because this Docker image is a public image available in my Docker Hub account. So this is a public image. Anybody can pull this Docker image. Once the Docker image got pulled, you can verify whether image is available or not. Docker images. Can you check it? So 23 months ago, I have created this Docker image. Around 2 years, almost 2 years back, I created this Docker image. Ashok IT / Spring Boot REST API is my image name. Now, can you tell me the command to run this image? This is my Spring Boot application, which I have Dockerized. How to run the image? What is the syntax? Docker run. Either you can take image name or you can take image ID. I'm using Docker run image ID. Now you check it. What is happening? Wow. It is running our Spring Boot application. Is it running our Spring Boot application or not? But do we have Java in this machine? Do we have Java in this machine? No. Then how this Spring Boot application got executed? How this Spring Boot application got executed? Docker is taking care of that. To run my application, Java is required. So what I have done for this project? For this project, I have created a Docker file. My Spring Boot application code is available. For that, I have created a Dockerfile. Using the Dockerfile, I created a Docker image. The Docker image I have stored in the Docker Hub. Now from the Docker Hub, I am pulling the image and I am running the image. When I run the Docker image, Docker container is created. Inside the container, my application is executing. Now, sir, can we access this application which is running in the Docker container? Can we access this application which is running in the Docker container? No. The answer is no. At this moment, you cannot access this application running in the container. The reason is virtualization. So this is my Linux machine. So my machine is available. The host OS is Amazon Linux. Okay. I have a machine. In this machine, I have Linux operating system. I created a Linux machine in the AWS cloud and I connected to this Linux machine by using MobiXtrom. Then in that machine, I have installed Docker. Then by using Docker, I pulled a Docker image. Using this Docker image, I created a Docker container. So Docker container means what? Docker container means what, guys? Docker container is a virtual box. Now, so in one Linux machine, another Linux machine is running. I know IP address of my Linux machine. I know IP address of my Linux machine. So which is the public IP of my machine. But the application is running in my machine. The application is running in my machine. The application is running in the Docker container. Guys, the application is running in my machine. The application is running in the Docker container. Come on, fast. The application is running in my machine and it is running inside the container. It is running inside the container. So is there any relation between this container and this host machine as of now? Is there any relation between the container and the host machine? There is no relation. There is no relation. That's the reason you cannot access that REST API. That is the reason you cannot access that REST API. Okay, I have taken one machine. In that machine, Linux operating system is available. That's okay. In that machine, I installed Docker. Fine. By using that Docker, I downloaded a Docker image and I executed a Docker image. When I execute the Docker image, Docker container got created. Docker container got created. But is there any relation between my machine and that Docker container? Is there any relation between my machine and that Docker container, or there is no relation? No. There is no relation. Got it. So then how we can access the REST API which is running in the application, which is running in the Docker container? This is not the right approach to run the container to access it outside. This is not the right approach to access the container outside. If you want to allow the people to access your container outside, you need to go like this. Docker pull -p 8080:8080 / docker run, basically docker run -p 8080:8080 and our image name. Sir, what is this -p? -p is called port mapping. I need to establish the relation between this container machine and this host machine. My container is running on the port number 8080. So I want to map that to the 8080 port. Okay. Container port is 8080. Host port also I am mapping to 8080. So if you establish the port mapping, then we can access our REST API by using host machine public IP. So currently my container is running, but that container is running inside the virtual machine. We can't access outside because we don't know what is the IP of the virtual machine. So virtual machine is created inside the host machine. I know the IP address of host machine, but my application is not running on the host machine. My application is running inside the container. Container means virtual box. I don't know address of the container. Then what I will do? I will establish the relation between container machine and host machine by using port mapping. So for that, we will use a flag called -p. -p represents port mapping. So when you are running your Docker container, you need to specify port mapping. Then you can access this application outside by using host machine public IP. You understand what is the purpose of the port mapping? It is used to establish the relation between host machine and container. Okay, so host machine container relation. What is the port number it is using, guys? My container using port number, my Spring Boot application running on the port number 9090. You can see here. Tomcat server started. Which port number? 9090. Java developers. Spring Boot will use Tomcat as an embedded container with default port 8080. But for this application, I changed the port number to 9090. So what is my container port number? 9090. So what I will do, that 9090, I will map to 9090 my host machine also. So host port and container port we are going to do. If you run application like this, then you can access that application outside. Let me stop the container, Control C, which is stopped. Now let us check it. Docker ps-a, my container stopped 4 seconds ago. It is exited. Okay. Now let me do Docker system prune -a. Delete everything. I don't need anything. Delete it. Now Docker images. Docker images. No images are available. Docker ps-a. Nothing is available. Okay. Now let me go and execute my image. Create a container. When I am running the container by using a Docker image, I'm doing the port mapping. The container is running on the port number 9090. Host port and container port is available. So if you do the port mapping, then we can access our REST API outside. Docker run -p 9090:9090 host port and container port, and this is my Docker image name. So pull I am not doing. Directly I am going for run. So it will check in the local. If available, it will run that. If not available, it will download and it will run that. So before, once again, I'm going to show you in my system, Java is available or not. In my host machine, Java software is available or Java software is not available. In my host machine, Java software is available or Java software is not available. Java software is not available. Okay, just run the image. Docker run -p 9090:9090 image name. So this is name of the image, public image in the Docker Hub. Now run this. Unable to find the image in the local. Now it is pulling that image from the Docker Hub and it is going to run that Docker image. You can see the console. My Spring Boot application getting started. It started with the port number 9090. I mapped that to the host port 9090. Now, so here, now be careful. We have created one container. That container port is 9090. That container port we mapped to host port. Port mapping we have done because I want to access this outside. Okay, I know the public IP of my machine. This is my machine public IP. My Linux machine public IP, which is running in the AWS cloud. In that Linux machine, Docker is installed. Using Docker, I executed a Docker image, Docker container created. For that container, I have done the port mapping. Now, to access our REST API from this machine, what we need to do? First, we need to enable the port number in the security group. Okay. So for this machine, go to security tab. At the time of creating this machine, we used one security group. Go to that security group, edit the rules, custom TCP 9090. I have mapped this machine to, I have mapped this container to 9090 host. Okay. So you need to go to the security group inbound rules and enable 9090. Okay. So in the AWS video, I explained what is the security group and all that stuff, guys. So currently I'm enabling 9090. The reason, my container machine My container running on the 9090. In the host port, I have mapped to 9090. That's why I'm enabling 9090 in the security group inbound rule. Save the rules. That's it. So we are good. Now we can access our REST API, which is running in the Docker container. So this is my machine details. Go to public IP, go to public IP, go to browser, public IP colon 9090/welcome/John. You give the name. Now see here. So this is my REST API URL pattern. Welcome. John is the name that is expecting as a path parameter. If I give any name, for that name, it will say a greet message. Welcome to Ashok IT. So if I give my name as Ashok, it will give Ashok, welcome to Ashok IT. So this is the URL of my REST API. So where is this REST API URL? Where is this REST API is running? Can you hit that URL? Give your name in the URL and test it. And let me know, are you able to access my REST API, which is running in the Docker container that is available in the Linux machine? The people in the Zoom, I gave the URL for testing purpose. Are you able to hit that? Are you able to hit that URL? Give your name and try that. Is it giving the dynamic response? From where you are getting the response? It is working. That's awesome, right? So now, if I want to run this application in the 10 environments, if I want to run this application in the 10 environments, do I need to bother about softwares? If I want to run this application in the 10 environments, do I need to bother about the softwares required? So what you need to do? If you want to run this Spring Boot application in the 10 environments, then what we need to do? Come on, guys. Just install the Docker software and run the Docker image. Install the Docker and run the Docker image so that your application will execute in any machine. Okay, now go back to our previous diagram. If I have multiple environments like this, if I have multiple environments, dev, SIT, UAT, pilot, prod, do I need to bother about versions? Do I need to bother about the dependencies? Do I need to bother about the versions? Do I need to bother about underlying operating system? Nothing. A big no. So our life simplified with Docker. As a developer, when you write the code, you can test that code in any environment. And the DevOps people, easily you can deploy the application into any environment with the help of Docker. That is the power of the Docker. That is the power of the Docker. Docker is called as containerization software. Docker is called as containerization software. So what is the meaning of containerization, guys? What is the meaning of containerization? Package our application code and dependencies as one unit for executing in any system. Code will be available. Developers will write that code. To execute that code, some dependencies are required. What dependencies are required, we will specify that in the Dockerfile. Okay. Once the Dockerfile is available, we will build that Dockerfile so that Docker image will be created. Once we build the Dockerfile, Docker image will be created. Once the Docker image is created, we can store the Docker image in the Docker Hub. Once the image is stored in the Docker Hub, then you can take that Docker image and you can run that image in any machine. In order to run the image, you need to install the Docker software. That is one part we need to do. Once the Docker software got installed, you can run the image. When you run the image, Docker container will be created. Once we run the image, Docker container will be created. What is the meaning of a container? What is the meaning of a container? Can I say it is one Linux box? Can we say it is one Linux box? Yes, it is one Linux box. Now you see, so many people accessed our application. So my application logs are generated. Welcome controller, welcome message, execution start, execution end, execution start. I implemented logging in my application. It is my Spring Boot REST API. So in this Spring Boot REST API, one GET request method I have implemented. For that method, I have implemented logging also. So the people are accessing my application. So the logs are generated. Can you hit the URL again? You can see the logs which are getting generated here. Now, can you guys see the logs are generating? The logs are coming here. The logs are scrolling or not? Yeah, dynamic logs. So application is running inside container. Container is running inside my Linux machine. So in one Linux machine, another Linux machine got created. That is virtualization. So with one image, we can create any number of containers. Container means virtual box. Containers created based on the virtualization. Okay. And here, one more small change, guys. Yeah, stop hitting the URL. Stop hitting the URL. So when my container is created by using this command, docker run -p and image name. Can I execute any other command? In this terminal, can I execute any other command, guys? Is my terminal open to execute any other command? No. Can I run one more container here? Can I see how many containers are running? Can I see how many containers are running? No. I'm not able to execute any other command. I'm not able to execute any other command because I am blocked here. I am blocked here. So let's make a small change. Let's make a small change. I want to run my container in the background, guys. I want to run my container in the background. So what is the meaning of running the container in the background? What is the meaning of running the container in the background? I want to run the container in the detached mode. Okay. So if I run the container in the detached mode, my container will be executing 24/7 and I can execute other commands also. Let me stop it. To stop this container, Control C. I'm going to press Control C. When I press Control C, the container got stopped. Good. So let us see Docker ps-a. So what is the status of my container? What is the status of my container? It stopped, exited. Okay. Now what we can do is Docker system prune-a delete. Everything is deleted. Okay. Now you can check Docker images, not available. Docker ps-a, not available. It is deleted. So what we need to do now? We need to run the container in the detached mode. How to run the container in the detached mode? How to run the container in the detached mode? To run the container in the detached mode, same command, just one option I have to add. Docker run -d. That's it. So earlier I used only -p for the port mapping. Now I am using -d. What is the meaning of -d? What is the meaning of -d? What is the meaning of -d? Come on, guys. What is the meaning of -d? Detached mode. Okay, execute. It is not able to find the image. It is downloading the image and it is going to run the image. Okay. Docker pulled my image and it is executing my image as a container. My container is created. Now, am I open to execute other commands? Yes. Now you can check Docker images. So it has pulled my Docker image. It pulled my Docker image. Then Docker PS. Now you can see my container status is up. My container is running and this is the port mapping. My container is running and this is the port mapping. You got my point? Now, can we access this application? Aram se, you can access it because it is running now. You can give the name, you can give any name and you can access it. Charles, welcome to Ashok IT. Yes, I'm able to access. Can you hit the URL and check it now? I am running my container in the detached mode, guys. I'm running the container in the detached mode by using -d option. Docker run -d, -p. -d means detached mode. -p means port mapping. And this is my image name. This is my image name. You got my point? You got my point? Good. So once you run the Docker image in the detached mode, is it printing the logs or it is not printing the logs? Is it printing the logs or it is not printing the logs? No. Then how to check the logs? For that, we can go for Docker logs container ID. It will show you the logs of the container. Docker logs container ID, then it is going to show you the logs of the container. If you run the container in the detached mode, logs will not be displayed directly. Then you need to check it. Docker PS will display the containers running. Then Docker logs, you need to give the container ID. With that container ID, you can check the logs of your container. You understood my point? Perfect. Any questions as of now? Any questions as of now? Yeah. So the another important part we need to understand Dockerfile. What is the Dockerfile? How to write the Dockerfile? What is the Dockerfile and how to write the Dockerfile? Okay. And there are so many things that are left, guys. So we need to understand how to write Dockerfile, how to write a Dockerfile, how to build Docker image, our own image, how to push Docker image into Docker Hub, how to push Docker image into Docker Hub. Okay. Then next one, how to get into Docker container. Container is a Linux machine. How can we get into Docker container? Okay. Then Docker Compose is available. Docker Compose is available. So basically, I want to integrate Spring Boot with MySQL database by using Docker. Then Docker with Jenkins integration. Okay. And how to deploy Docker containers by using Jenkins, Docker with Jenkins integrations. So a lot of things are there that we need to discuss. Okay. Docker with Jenkins integration part is also there. Fine. So we'll plan another workshop to discuss these things, guys. So today we thought of 2 hours, but it went around 2 hours 40 minutes. Okay. And for the Spring Boot Dockerization, the people who are asking how to write the Docker file for Spring Boot, here I have already uploaded the video, how to write the Docker file, how to create our own Docker image. That video I have already given, Spring Boot with Docker, Ashok IT. So I have explained deploy Spring Boot application by using Docker. So 20 minutes I have taken for this video. So in this 20 minutes, I explained how to write a Docker file in order to Dockerize our Spring Boot application. And I will make another video how to deploy the Spring Boot application with MySQL database and all that stuff. So due to time constraint, now I'm stopping here. So in this video, I explained how to write a Docker file. So this is how we are going to write a Docker file to Dockerize our application. So like this, the Docker file we are going to create. Once the Docker file is created, Docker build command will be available. Using Docker build command, you can create the Docker image. So this is the command to build the Docker image. Once the Docker image is created, you can run the Docker image by using run command. Okay. So this video link also I'm going to share, and I will conduct one more workshop in the coming classes. So in that we are going to discuss the remaining parts left in the Docker. Okay, cool. So all of you join in this WhatsApp group so that you will get these notes and required videos and backup video on this one. Okay, good. Thank you all of you. Thank you all of you for joining today's workshop. So I hope you enjoyed this workshop. So it's very knowledgeable. Almost 2 hours, 30 minutes we spent for this. I hope you enjoyed it. Thanks for your time. And once again, all of you, welcome to Ashok IT. We'll catch up soon. And you are part of that WhatsApp group. The next workshop date I will update in the WhatsApp group. And today's class notes, class video, any other videos, the references, AWS video, those things I'm going to share in our WhatsApp group. The people who are watching in the YouTube, please join in that WhatsApp group, guys, so that you will not miss any update. Okay. I have shared a WhatsApp group link in the YouTube live chat also. I will share these notes and the required videos and documents in our WhatsApp group. So please join in that. Once again, I'm sharing this WhatsApp group link in the YouTube live chat. You can join. For Zoom people, I have already given in the Zoom chat. I will update about the next class in the WhatsApp group. So we'll work on the pending areas in that. YouTube people, please like this video and subscribe to our channel for more updates. Give me a comment how you felt about today's workshop. For documents, join in the WhatsApp group. I'm going to share the documents in the group. Thank you so much, guys. So thank you, all of you. Have a great day. Happy weekend. We'll see you soon.